There's one more very basic counting principle, and we illustrate it with this example. Let's say that we have 20 people in a room, 12 male and 8 female, and 7 of the people are blonde and 13 of the people are dark-haired. Now, that gives us 12 males and 13 dark-haired people. But 12 and 13 add up to 25. And we only have 20 people. What's wrong here? You really need to pause and ponder this problem for a minute. Hopefully you've paused and pondered. If there are, well, the key here is, what's wrong is that these are not mutually exclusive sets. Okay, some of the males could be dark-haired, and some of the dark-haired people could be males. Certainly are, since these numbers add up to more than 25. So, there's some overlap between the dark-haired and the males. Some of the dark-haired are males, some of the males are dark-haired. And if we add the 12 to the 13, we've counted everybody who's dark-haired and male twice. Okay, the 25 counts each dark-haired male twice. And there's the flaw in that argument. Now to look at what's really going on with numbers, we can use the pictures of a set again. If A, let's say, represents a set of dark-haired people and B represents the set of males, we see that there's an overlap. And that overlap is indicated in set theory by A intersection B, the intersection of the two sets. If we want the number of people in the sets A and B, okay, again, if A is the males and B is the dark-haired, then A union B let's go ahead and just label these male and dark. Okay, A union B is what we get when we lump these two sets together. That is the set of dark-haired males. Now the number of people in that set A union B, well, if we add the number in A to the number in B, we get that 25, which is too big. Since we counted everybody in the overlap, A intersection B, twice, we'd better subtract the number in A intersection B, the number of people who overlap both categories. Okay? These are the people who are counted twice because we count them when we count the number of people in A, and they're also counted among the people in B. So if we add the two numbers, these people will be counted twice. To get the actual number when we group the two sets, we're going to have to subtract the ones that are counted twice. Then they'll only be counted once. So here's our general principle. And your textbook gives you several examples of how this principle is applied.